So of course vision is very important for us because we use vision to orient in space, and that's a very important signal or information that we use to guide our locomotion. But if we have a plan, if we know where we want to go, there's other signals that are also coming from sensory systems, sensory signals other than vision, that can actually tell us whether our intended trajectories and our intended pathways are executed as intended. And one of them is the vestibular system, for example. So our sense of balance is also very sensitive to acceleration signals, linear acceleration signals. So the brain could use these acceleration sensitive sensory signals to actually determine, for example, if we started to move on through space, or if we're changing velocity, or if we're turning around. Other signals that the brain uses and that are important actually in controlling locomotion are the signals that are generating the motor commands themselves. So the brain, once it wants to do something with the body, sends these motor commands so that the muscles are contracting in a particular way that we can actually move our body through space. So those signals not only go into the particular motor centers controlling locomotion, but copies of those signals are also broadcasted many other areas in the brain. And we think of these signals called chloride discharge signals that are also very important in actually controlling our locomotion. And finally, we have all the sensory modalities that are related to our sense of touch. One particular system that is called proprioception, which is a system that detects actually the tension of the muscles. So it's a system that is also very important in controlling a little bit more specific details of our gait and steps as we are actually moving through the space. So in general, there is all these multimodal sort of signals that are all put together in the brain, and they're very much used to actually very well control our intended courses. So we're trying to first understand exactly how the brain interprets visual signals that are actually generated when the animal moves through the world. And because we know a lot more about visual processing in general in Drosophila. So our strategy is to start with things that are already better known and understood and put them in the context of locomotion. And what we have found actually is that there is a lot of interactions between visual and non-visual signals in what has been classically defined as pure visual networks. And so now we're identifying these non-visual elements, and we hope that by actually reconstructing all the identities of the neural circuits of the non-visual information, we will get to know what neurons out of these different sensory modalities I was telling you before are actually also involved in the flight, in controlling the locomotion of the animal.